I'd like to give you a little bit of perspective on microcontrollers that you can connect to the internet so that you can communicate with the outside world. This is the one that I like best right now. It's an Adafruit Feather with a SAMD21 M0 processor on here, so there's a 32-bit microcontroller there. And it's got a completely separate WinC 1500 Wi-Fi system on board. Now this is the most expensive choice, but it means that the Wi-Fi system manages itself and the microcontroller can be full-time doing your control application and only send or receive some stuff from the Wi-Fi when it really has time to do that. I really like this one, but I've experimented with some other options. For example, this is the ESP8266 package. And it has the advantage of being a self-contained Wi-Fi unit and microcontroller, also programmable like this one with the Arduino IDE, but costing much, much less money. So this little guy, small, light, easy to handle, doesn't make a complete microcontroller. For a start, there's nowhere where you can plug it into a USB to talk to the IDE. Now, Adafruit has taken this 8266 and put it together into this breakout board, which is mostly just enough room to have this 8266 and the supporting circuitry it needs, including these two push buttons for reset and input-output control. So you can plug this one in, and you can talk to it from your computer with an FTDI cable and program it directly. This is a more expensive solution than that, and so I decided to see, well, what would it take to roll my own and put together a package that would do the same things as this, but maybe not cost as much? Well, the answer is you need to have some of these, and these are really close pin spacings with surface mount capability, so you really need something like this that you can mount it on. And then you need to do some soldering to attach that. That's what I've got over here. So now I've got it attached, I can actually plug it into my breadboard and make some connections. But in addition, to make this work, I'm going to need a capacitor on the power supply, and I'm going to need two buttons, like those two buttons. And this one has got a little LED on it here somewhere, right in here. I know there's an LED there because I've used it. So I had to add an LED so that I could know what was going on with the buttons. And finally, to manage the power, I need a little 3-volt regulator over here. So there's a bunch of additional components, a couple more resistors. It gets fairly complicated to put this together. And by the time I've done this, even if I don't count anything for my labor, I'm getting up close to the price of just buying one of these. So long story short, it's probably worth buying a packaged unit rather than trying to put the pieces together yourself, unless you're looking for a challenge. So I've tested this one. It works exactly as well as this one. However, I don't think I'm going to ever use this one in a practical application. So the options you've got, something like this, the M0 with the separate Wi-Fi, that'll be a little bit more costly, but it's a lot easier to operate. It gives you an independent microcontroller with lots of analog to digital conversion. This version in the middle, roll your own, don't even bother. Down here, the packaged ESP8266 winds up being a pretty good solution, but its two big weaknesses are, one, it's only got one analog to digital converter. And the other is, because it's got all of the things in one single package here, the microcontroller is spending significant amounts of its time talking to the Wi-Fi network, which means that if your control application needs to have continuous attention, it may have a latency of maybe half a second before it gets to certain tasks. And often that won't be acceptable for anything approaching real-time control. So I've used this in a bunch of projects, but I like this one much better.